Hello everybody and welcome back to this tutorial, and right now what we are going to do is we will see how we can hide our reverse shell. So in the previous videos we saw once we actually ran the reverse shell, it was rather here on desktop, and the user could simply just delete the file as soon as they run it, right after they close it with Task Manager. So they would be like, why is this file not running? It's not opening anything, I do not need it, and then they would delete the file. But what we can do is as soon as they actually open the file and run it, we can actually make a copy of that file into a different directory where they will never find it. So for that directory, we will use a hidden directory in Windows called the app data directory. We will hide our copy of our reverse shell there, and then we will try to create a persistence which will allow us to actually run our reverse shell right after the target restarts their computer. So basically what we are doing in this video is we are hiding the program and also creating the persistence for our backdoor. So let's see how we can do that. In order to do that, we will need to import a library in order to copy our file. So let us nano the reverse shell first of all, and import a library which is called shuttle. So import shuttle right here. And where do we want to actually create the persistence itself? We can actually create it at the beginning of the code. So before it even connects back to us, it will perform the copying of the file and then it will connect back to us. So what we can do is we can create a variable called location, which will store the location to the new path of the actual place where we want to copy our backdoor. So we will specify that place with os.environ, and in the brackets, in the square brackets between the double quotes, we need to specify app data. What this will do is it will find the app data path on our target PC or on our Windows PC. Now make sure once you run this reverse shell, it is a Windows target because app data folder doesn't exist in the Linux systems. So let me show you where it is. If you open your command prompt, and at your path of your user, just there you can just type cd app data and you will be in the hidden directory. There you can just type dir and you will see some different directories as well. Now the path where we are going to actually save our hidden or our copy of our backdoor will be in the roaming folder in our app data path. So this is basically the path of app data, and this function os.environ will return this path right here. All we need to add to this location is the name of the file, so we can add it like this. Plus, since we can concat the strings in actual Python, we specify right here / in order for this to actually work, and we can name the copy of our file anything we want. So let's name it, for example, windows32.exe. Since that looks something, or it basically looks like something that could possibly exist on target PC. So even if the victim or the target actually found this file somewhere, they would probably not worry about it since it pretty much has a normal name. Now you can call it anything you want as long as it has .exe extension, and make sure to close the double quotes right after it. So right now what we're going to perform is checking if this location exists right after we run the program. Now the reason why we are checking if this location exists is basically what happens if we actually run this file twice on the target system. So in the first time it will actually create this path with the file right here. We do not want to create it a second time. We only want to create it once. So in order to do that, we can just type here location, or not location, we can just type if not os.path.exists. And this function will basically check if a certain file at the specified path exists, and our specified path will be location. So if it doesn't exist, we want to create it. In order to create it, we can just use shuttle.copyFile, which is a function that will copy a file. Now we want to copy our executable, which we can specify with the sys.executable. It will specify the actual executable that is running in this program and the comma, and then we need to specify the path where we want to copy it. We want to copy it in location. Now in order to use sys.executable, we need to also import a function called sys, or pardon me, not a function, a library called sys. So once we copy the actual file, we want to create the persistence. Now this is an optional, you don't need to create the persistence if you don't want to. I will show you how you can do it. There is one command which you can run in your command prompt to create persistence, which will basically add a registry key to your Windows 10 machine. So let us do that. So subprocess.call. In the brackets right here, since we are using subprocess.call, what this will do is it will execute the command. We need to specify this command, so just type everything. I type open single quote, reg add HKCU capital backslash software backslash Microsoft backslash Windows and then backslash current version and once again backslash run. Then space. Then not space outside of the bracket, so space, the normal slash small v, then the name of the actual registry key that you want to create. So I will just call mine, in this case, backdoor. Doesn't even matter, call it anything you want as long as it is one word. Then the type of the registry key we are creating, it is reg_cz. I will show you later on where you can find all of this. We also need to specify the /d option, then close double quotes, then close single quotes, then add the actual location with the plus, so we can concat a string. So plus location, plus, and then single quote, double quote, single quote. And then comma, shell equals true. Oops, T has to be capital. And this is the entire actual command. So what this will do is it will create a registry key, which will make our file run after every restart. It will create a registry key at this path, so it is a registry key at the current user host key, or pardon me, H key current user. Let me just show you how to get there. You just type in your search bar right here. You can type run, and it will open up this small window where you can type regedit. It will prompt you for the administrator password. You just, since I don't have, I will just type yes, and it will lead you to a page like this where your registry keys are. So we can see we created in the H key current user, since H key CU is the name of our path. Now make sure to not delete anything from here that you don't know what it is, since it can actually crash your PC. So right now we go to the same path that we actually specified right here. We click on HKCU, we want to go software, Microsoft, Windows, current version, and then run. So let us go H key current user, software. Then we need to find Microsoft, which will be under M. So let me just find where M is. Here it is. Then what we are finding is the Windows. Okay, so here it is. Current version, and then run. And right here is the place where we actually want to create a registry key. And basically this run path right here are all the files or all the programs that will run once you actually restart your PC and log in to the same account on your Windows 10 host or any Windows host at all. So basically, once we actually run the program right here, we will have something called backdoor, which will be the type of reg_cz, and the data will be the path to our file that we copied. So it will be the path to the app data folder where we have windows32.exe file, which is basically just a copy of our backdoor. So let us just tab this down. Let's see what else we need to type right here. Basically, this is for now on enough. We don't need anything else. Let me just check if this command is good enough. Then we proceed to create the socket object, and then we enter the shell. So let us see if I save this, exit. Now we want to compile the program once again. So wine/root.wine, drive C, Python, and then scripts, PyInstaller, -- no console, and -- one file. Now we don't need to fix anything in the server code, since this is something that will only run in the actual reverse shell. Now here it is prompting me this because I forgot to specify the file that I need to compile, which is reverse_shell.py. Okay, so we will see how this will work. Right now we don't have anything named backdoor right here. And also if we go to our app data roaming folder, so open your command prompt, go to your app data, which you can just go to your actual user account and then see the app data and then see the roaming and type dir right here. Right here is where we will have our Windows 32.exe copy of backdoor once we execute the reverse shell, or once the target executes the reverse shell. So let's leave this open as well as this open, and let's unplug our USB drive in order to transfer the actual reverse shell. So let me go to this directory, move the reverse shell to media, root, and the actual USB drive. Let's see, why is it not plugged in yet? So USB, let's unplug it and plug it again. For some reason it won't plug in. Okay, so let's wait for it to plug in. There it is. Right now if we move the reverse shell to media, root, Kali live, takes a few seconds. You can also transfer this reverse shell over Apache 2 web server if you want to, whatever you find easier. For me right now I will just use the USB drive because it comes pretty handy and I believe it's faster, maybe not. But just make sure that you know that once you actually download the file from the internet or from the Apache 2, it will prompt user saying this is an exe file, would you like to run it? But that actually comes with every file that is actually exe download from the internet, so it doesn't have to do anything with the viruses, so don't worry. Right here we want to go one directory back and run our server.py. Let us actually remove the USB drive. Type right here, or put it right here, and then run it. Let's see if our reverse shell.exe will work right now. So as soon as it connects, and it already did connect, we can execute commands. So what this means that it already completed the process of copying the file and creating the persistence with our registry key in our HKey current user registry. So let us see. First of all, check the command prompt. Right here, you cannot see any Windows 32.exe folder or file. If you type here once again, let me just find it. Here it is. So right now, we do have a Windows 32.exe, which is a copy of our backdoor. And if we go to our actual registry edit, when we refresh with F5, we can see right now we have a new registry, which is the backdoor. It is called backdoor. Now you can call it anything you want, just specify in the actual reverse shell the different name. If you think this is actually noticeable, which indeed it is, and we can see the path to the program that it will run at the startup, which is the path to our Windows 32.exe. And right now, even if the actual target took this reverse shell and deleted it, and even if they shut down their PC and turned their PC tomorrow, or in 2 weeks, or in 2 years, you would still be able to connect back, or basically to connect to their target PC and execute the commands. So let's just close this, since we don't need it. Even though, let me show you, even after you actually delete this, so it is deleted, but it will still remain in here. So that would be about it for this tutorial. We saw how we can successfully create persistence. We hid our backdoor into a different file. And in the next video, we will see some of the different options we can actually add to our reverse shell. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody, and welcome back. And in this tutorial, we are going to see how we can actually perform the connection to the actual server every 20 seconds. So you might have noticed that every time we actually tested our reverse shell, we needed to wait, for example, before we actually ran the reverse shell, we had to set up our server in order to connect back. Now what, for example, if our target suddenly opens the reverse shell without us listening for a connection? It will not be able to connect back to us, and it will basically just close the program, and we will not be able to execute the commands or do anything else to target PC. So we want to implement something in our reverse shell which will try to connect back to our server basically every 20 seconds, or doesn't have to be 20 seconds, it can be any amount of time you want to specify. So in order to do that, let us go to our reverse shell. Oops, let me just delete from the previous compilation unnecessary files and folders. so we can only have these two files. Let us also delete the hello.txt and test.txt, and let us nano the reverse shell.py. Right here, what we want to do is, instead of this connection right here, first of all, what we want to do is delete it. Since we don't want to connect right here, we will make a simple function which will do that for us. So just delete this right here. Oops, not everything. So socket.sock_stream. Okay, and right here, we will basically just call a function which will be called connection. So this function is the function that will perform the connection. Just go up here, right here, go up, and we can code the actual function right here. So def connection, open and close brackets, let's add the two dots, and in order to be able to actually execute the connection every 20 seconds, we need to run this in an infinite while loop. So while true, we will add something called sleep, which is a function that comes in the time library, and in order to use it, we need to import time. This is a library which will allow us to use this sleep function, which will basically just not execute any part of the code for the specified amount of time. So this sleep function actually takes one argument, which is the amount of seconds you want your program to sleep. In our case, we will specify 20 seconds. And after that, we can try to connect. So try sock.connect, open double and open double close brackets. And between the double quotes, we need to specify the IP address, which in my case is 192.168.1.9, which is the IP address of my Kali Linux machine. Then comma, and the port that we are listening on. So in my case, 54321. And after that, once it connects, we can actually enter our shell from here. So if we are entering our shell from here, we don't need to have the shell specified right here, so we can delete the calling of the shell function from here, and we will call it from the actual connection function. In case it doesn't actually manage to connect, that means that our server is not open and running, and it is not listening for connections. So in that case, we will call connection function once again. So this is a recursive function. It basically calls itself. As you can see, we call the function connection from the connection function, and this will go in circles until it manages to connect to our server. So for example, if someone ran this reverse shell and then 3 hours later you actually opened and started your server, it would actually connect to it even 3 hours after running the reverse shell. So let us save this. Time sleep, 20 seconds, everything is good. We can now try to compile the program. So wine, root.wine, drive C, Python 27, scripts by installer. Okay, so no console, one file, and then reverse_shell.py. Let's press enter right here. Let us import the USB drive. And right now what we are going to do is we are going to run the reverse shell first, then we will wait a few seconds, and then we will run our server in order to see whether it will connect or not. So let me just go right here, go to dist, and move the reverse shell to my USB. Also, since we already have from the previous video the copied backdoor into our roaming folder and also a registry key in our registry editor, this reverse shell right now will not perform the persistence since it already performed it in the previous time we actually ran it, as you can see in the actual code. So let me just go right here. It is good to know that .py. You can see that we coded right here that it should not perform these two commands in case this location right here exists. So since it does exist, since we coded it last time and we actually copied it, it will exist, and it will just skip this part right here and it will go straight to the socket creation and then connection function. So that is good as well. Let us run our server. Let us unplug the USB drive, copy the backdoor or the reverse shell to the desktop, run it. Oops, we actually made a mistake. Let's wait for it to actually connect. We should have waited 20 seconds and we should have ran the reverse shell first. So what I will do is I will just close as soon as this connects. I will just press Q to close the connection, and then I will start the reverse shell once again and just basically wait a few seconds before starting the server. So I quitted the server. Let us start the reverse shell once again. Okay, so it is started. We can see nothing is opening, nothing is running. Basically right here, we don't have our server opened. Now let's wait a few seconds and actually start our server. So clear the screen. There wasn't really point to clear the screen, but doesn't really matter. And let's right now run the actual server. It is listening for incoming connections even after we run our reverse shell. And right now, hopefully, we will get connection back. So let's wait a few more seconds since we specified the timeout to be 20 seconds. So in less than 20 seconds, we should connect to the target. And we did, so we can see we got a connection from our Windows PC at this port, or the connection is from this port. We can execute the commands, we can do anything as in the previous videos, so our actually persistent with the timeout of connecting actually works right now. So at this point, all you need to do is deliver this reverse shell to the actual target, and you will be able to connect to them anytime you want, as long as their PC is on. So that will be about it for this tutorial. I hope you enjoyed it, and in the next video what we will do is we will see how we can actually download some files from the internet with our reverse shell. Hope you enjoyed this tutorial, and take care. Bye.